All right, very good. So I guess we're going to do like a little free-flowing conversation between us, just so the Telos community get to know some of the key people involved in some of the work we're doing these days. I guess with brief introductions, maybe Alberto, you can tell us a little bit about yourself, your background, and how you got into Telos.
Sure. I'm Alberto Garofolo. I'm head of ZK at Telos. I joined crypto in 2017. At the time, it was Zencash with the focus on SNARKs, and in particular, using recursive SNARKs for scaling blockchains for sidechain systems. So I kept working on zero knowledge and on this kind of development, and then I moved to IOG as the head of engineer of the Midnight project, always with the focus on zero knowledge technology. And now here, I'm at Telos to, let me say, scale and to make zero knowledge proof verification efficient. And so, it's a very great journey ahead of us.
Yeah, wonderful. Okay, and maybe Slobodan, you can also just give us a little bit of background on yourself, introduce yourself to the community.
Well, thanks. I'm Slobodan Lukovic. I actually got my PhD in embedded systems something like 15 years ago. Then I decided to move a little bit to different kind of topics. And just a few years ago, I think that the stuff that we were actually doing during my research period of my academic research, they got something like very interesting and nice application, which means scaling blockchains. So we embarked on this kind of work as Ponus Technologies. I'm CEO of Ponus, and we are here to help Telos, and in particular SNARKtor, become efficient, low-cost, low-latency solution for further scaling of blockchains. That's in short.
Super good. Yeah, well, actually, let's stick with you. So one of the things I learned from you, and one of the things we've been talking a lot about with our community, is the importance of hardware-software co-design. And in particular, in the context of obviously scaling blockchains and achieving very high performance. So maybe in your own words, if you can kind of talk about the importance of that, maybe some of the work you've been doing, some of the research you guys have been doing. Basically what we're trying to communicate is really that it's very, very important to take a co-design approach from the start, that you have to think about both the hardware and the software from the very, very beginning. So maybe you could talk a little bit more about that, please.
Yeah, well, basically, blockchain technologies are perceived by wider community, and basically it's a kind of true that they're still, we may say, slow or not fast enough, quite costly, and not so much user-friendly when it comes to developer community. And to tackle these kind of problems and in a way resolve them, a kind of hardware, software, co-design optimization approach should be taken from initial design up to final deployment. And the idea that we actually are kind of bringing to this field is to have end-to-end approach into entire life cycle of one project, in particular starting from designing primitives that are built in hardware and optimally integrating them in the rest of the software. In order to build this kind of fully optimized system, this hardware-software co-design thinking has to be taken into consideration from early design, and that's the only way to resolve this kind of trilemma that we have mentioned at the beginning. In other words, ad hoc solutions and that are mostly used currently or so far by resolving one or another problem per se, in my opinion, won't yield with a solution that will bring performance of blockchains to another level, still keeping security and low cost of utilization of this technology at some acceptable level that would enable, let's say, wide adoption in regular industries and in wider community. So in my opinion, that's why it's really important to have this kind of custom-built computing infrastructures, I would call them, completely optimized and matched with the user use case requirements and use cases that we are considering.
Yeah, that's one of the things we've often talked a lot about is really understanding the use case from the start, thinking very carefully, and then kind of factoring that into the design. And I guess more to your point, I guess sort of what we're potentially talking about is a future where there's a true system-on-chip design and solution. And so I'm just wondering if you can kind of like give a little more context, some of the nuance here. So it's kind of like, you know, this ad hoc approach, and then you sort of somehow plug in some hardware and like magic happens and you get this like incredible performance is not actually, I mean, it's very, very hard to imagine that actually, you know, happening in practice. And so just thinking about, what does a future roadmap look like, you know, in this system-on-chip kind of direction that we're hoping to achieve in the future?
Yeah, basically, I usually say you cannot take a engine of Ferrari and put it in Fiat.
Yeah.
You can, but does it make sense, right? You have to build the system in such a way so that this kind of powerful engine can be fully supported and to complete and to benefit all the power that it can bring to the system. And this is what we are trying to do. We are trying to build a vehicle that will be fully optimized towards needs of some particular use case or general purpose use cases, and that's our approach. On the other side, in general, speaking about hardware acceleration, people usually have two things in mind. On one side, that's GPUs that basically have their limitations, and on the other side, on the other extreme, it's ASIC. But and it's taught quite a lot about this technology in blockchain community recently. But there is a kind of problem with ASIC as well, because they require really huge, significant initial investments, and we need to have standardized solutions. Like, for instance, if everybody can recall a blockchain and a SHA-256 hash function that was standardized solution for blockchain consensus, and basically it was quite natively transformed or implemented in ASIC, and that's what we have now. In blockchain, in Ethereum community, in particular, speaking about ZK space, which is really dynamically changing, we don't use standardized hashing functions, for instance. So it's a kind of still early to talk about ASICs, even though they are definitely a kind of final solution once we are sure about which kind of ZK protocol we are going to use. On the other side, in a kind of the solution in between that we are using currently are FPGAs, which are flexible enough, and on the other side enable fully pipeline and parallelizable design of critical underlying cryptographic primitives. And as mentioned at the beginning, we are optimally integrating that in the rest of the system by matching entire data flow, by optimizing memory footprint and so on, in sense that entire system actually breathes in a synchronized and a fully optimized way.
Yeah. By the way, I own a Fiat. I love my Fiat.
Me too. It serves the purpose.
It's electric Fiat. It goes pretty fast. But,
combining the two, I mean, depends
idea.
on user requirements, right?
That's right.
What you expect.
Okay, so maybe switching gears, Alberto, we could kind of ask you a little bit. I mean, obviously you've been thinking about ZK for a very long time. You are one of the co-authors of the SNARKtor white paper. So I'd love to hear some of your thoughts on, first of all, if you can kind of briefly describe SNARKtor, your thinking that went into it, talk a little bit about recursive proofs, and then maybe later we can get into provable computation and some of your thoughts on parallelization as well.
Yeah, definitely. Okay, so I mean, let's start probably from the reason we started thinking in the direction of SNARKtor, no? I mean, currently many use cases are not possible on blockchain for many reasons. For sure, scalability, as we just discussed, but there are others, like user data protection, that is a fundamental thing that, I mean, currently is not so highlighted. So you're not seeing many use cases that would require the user to share some sensitive information on chain And I always do this example of the car rental. Let's just imagine to implement a simple car rental application on chain. The user would require to share his driving license information to prove that he has a valid driving license. And as for this use case, there are so many others that are not possible on blockchain for these reasons. And so, I mean, and we can go on and we can speak about also compliance with government's rules. That is something that is a need that is arising. And so also in this case, having, for example, to share how our, let's say, the user digital identity on chain is something that is not acceptable. And so zero knowledge become fundamental for solving this kind of issue, and so providing the possibility for the user to keep their data private, sharing the proof without sharing the data, and having the application having the possibility to verify statements on user data without having the data. And this creates the possibility of many more use cases. But now there is another problem. We need to be efficient in verifying zero-knowledge proofs. And this is the challenge that SNARKtor want to solve. So SNARKtor has been designed to have efficient zk-SNARK verification on chain.
Yeah. Well, you know, I actually use your example all the time. I did it in my talk this morning. I think it's very elegant. I mean, it speaks to kind of the ultimate, in my opinion, utility of the blockchain, which is to realize self-sovereign identity.
Correct.
And so you can further expand on that and sort of say, well, selective disclosure, granular authentication, while still preserving data protection, giving the user the opportunity to use the blockchain without necessarily compromising all of their information.
Yeah, it's, let me say, I would not call it privacy because it's much more than privacy.
Yes.
I mean, it's even beyond. So let's say, just doing this other example, a developer want to implement a casino game application on chain, just as an example. You want, the developer want to be sure that the users are over a certain age to join the game.
Yes.
And it's fundamental to be compliant with the government rules, for example. And you will not share your digital identity information or your whole digital identity information on chain with everybody for the rest of your life, right? Or even more, I mean, because it will stay forever.
Yes.
So with zero knowledge, you can create a proof, the user can create a proof on his computer proving that he has a valid digital identity and that he is over a certain age. And in such a way, he will preserve private his data, but at the same time, the application will have the possibility to be compliant. So that's a fundamental thing that will enable so many use cases that currently are not possible.
Yeah. Yeah, and you mentioned user-generated proofs. I guess that's something we've talked a lot about at Telos. We think that users are going to be generating lots and lots of proofs. So that sort of then means you're going to have a future where you're able to do that on a mobile device.
Correct.
And obviously that's a hard problem, but I know you've done some thinking in this direction, and I'd love if you could share some thoughts on basically user-generated proofs on mobile devices and what that future could look like.
Yeah, sure. So we are trying to preserve the privacy of the data of the user. So it's fundamental that the user generates the proof himself. So one option, for example, if you imagine an application, now everybody uses a mobile phone, so is using an application on mobile, and then if he has to create the proof, he has to create the proof on his mobile device. So what we have been working, so not only thinking about, but we have actually did it, a demo of, let me say, of a program that was able to leverage, for example, RISC-0, a well-known zero-knowledge virtual machine.
New friends of ours, very nice people.
Yeah, they are. And so we were able to run RISC-0 on a mobile device. And also, I mean, but we will go maybe later more in details, we were able to leverage the risk-zero proof generated on the mobile device with SNARKtor in order to make it more efficient hits verification on chain. So you can now see the big picture where users are generating their proofs on their devices, and then they send these proofs to the SNARKtor network. The SNARKtor network aggregates them, and I'm going forward, but just to provide an overview. The SNARKtor network aggregates them, and then the final aggregated proof goes on chain, and this makes the SNARK verification much more efficient and less expensive for the user.
Yeah, so that kind of segues, maybe Slobodan, you can kind of give some thoughts on this to, since we're talking about like where this could go in the future. There's obviously going to be fees associated with requests for proving, as more and more users demand proving services. So maybe you could talk a little bit about how you imagine the proving markets developing in the future. What that kind of looks like, some interesting potential applications or, market arbitrage opportunities that could exist, and just how you imagine sort of like the proving markets rolling out as more and more users demand proofs.
Yeah, basically it's spoken quite a lot these days in the community about proving markets. There is, first of all, the problem that I see here is there is no still a kind of proving demand for establishment of economically viable proving markets. But provided that we expect that use cases that will bring ZK proving demand to much higher levels are going to come very soon, we may say that this is absolutely needed and native next step that will come as soon as we have use cases that bring TPS at some higher levels. And in my opinion, it's something that we should that we have seen. For instance, like in cases, let me give you a few examples. Even for some interesting use case interesting for engineers is real-time operating systems. You have certain budget and certain deadline by which your task must be executed, otherwise system goes down. It's the same thing with proving. Some use cases, some applications require lower latency, especially if we speak about DeFi. Some of them don't care much about latency, but care about cost of proving. And that's the entry point, and that's the driving force for proving markets. Because on the other side, we will have machines, and Ponus technology has actually implemented and demonstrated different kind of options for either lower latency and higher cost, or vice versa. So we have practically entire setup for establishment of proving markets. The only missing thing is something that Alberto should enable. It's a kind of growing ZK proving demand. I may give you another example that might be more familiar for wider public. It's Google Ads, for instance. You want your ad to be presented in here or there, and of course you have a budget and you have a time. But if you promote an event, it can be like in 2 weeks, and by 2 weeks you want this budget to be exhausted, and of course you cannot be promoted, and then you are bidding for different kind of let's say pages in which this ad should be displayed, and the more views on page, the higher the cost of display, and then you have your limited budget. And similar problem in this, these are actually constraint optimization problems. Proving markets will face sooner or later. We are seriously considering, and not only considering, we started seriously working towards protocols that will, by the way, one of them has been, one of protocols has been explained and described by SNARKtor. On our end, we are seriously working together with Alberto and his team on making those proving markets being very efficient and performant, having in mind that we have a lot of experience with similar kind of problems. So that's another aspect that Telos is also taking very seriously from an early beginning of this next stage of development. and we are absolutely ready to respond to any kind of user requirements also with that respect.
So, and Alberto, I'll come to you in a second, but before I do, I just want to ask Slobodan one more question, just to follow up on this, because I think it's going to lead to something spicy with Alberto shortly here. But you talk about, so it's kind of like a chicken and egg problem. On the one hand, the proving markets will manifest, and we think they represent a tremendous opportunity in the future, but they require tremendous performance improvements, okay, which actually then enable user demand, right? Because currently today, very few users are going to be willing to spend a lot of time and a lot of money, which is sort of the current state. So I'm just wondering, and then of course that kind of transitions to ultimately, as you said, imagining ASICs being the end game, right, where you can actually achieve those types of performance characteristics in order to enable cheap and fast proving markets to exist, where users can then actually use them, which sort of enables the demand. And I guess I'm just wondering if you could talk a little bit about the current state, like the order of magnitude in terms of improvements that we're talking about here, right? So like currently today, it's going to take some time and cost a lot of money, and to kind of like generate a proof. And what we're working towards in the future sort of is, I just want you to kind of paint a picture of the current state and the scale of like the types of improvements that we're trying to create here.
Yeah, well, I'll try not to be so technical in this discussion, but I would say that, let's say, depends on proving protocol, ZK proving protocol, there are different kind of bottlenecks. And in particular, speaking about SNARKs that we are mostly relying on, hashing or merkleization and so-called entity or numeric theoretic transform are the key bottlenecks. What we managed to do is we practically provided FPGA solutions for these two critical models that are more than 10x faster than whatever you can achieve with regular general purpose software, and that are, by the way, outperforming anything that's out there at the market. At the level of entire proof depends actually on the rest of the protocol, because mostly it can be like 50 or 60 or even up to 80% of entire proving time that goes to those two modules, so that this directly reflects to the improvements that we can have at the level of entire cost. So those proofs can be achieved, for instance, in 20% of time. If you wish, it's kind of 5x, speaking time-wise. But mind also that this reflects at the cost as well. And the cost, if you, for instance, perform this kind of computation at some kind of custom-built data center, can go down for 20x or even more. Yeah. And that's what we actually implemented and demonstrated. So these are, let me say, some numbers speaking about proving that we can achieve by implementing solutions that we are not only proposing, but solutions that we actually have implemented already.
Yeah. Okay. So maybe Alberto, I'll just, let me ask you a random question, okay? Maybe it's not so random, but tell me how you feel about Ethereum proof of stake. And tell me how you feel about Ethereum as a ZK execution environment in its current state. And feel free to be honest.
Okay, I mean, for sure, proof of stake provided so many, let me say, advantages in terms of efficiency, in terms of power consumption, but still, in its current form, there are still some centralization issues. And so taking into account these aspects when designing a new network is something fundamental, I think. So we're taking into account these in order to, generate a new version that could mitigate such centralization risks and at the same time, incentivize and provide also a fair reward for the hardware acceleration part. So if you are able to put together the proof of stake advantages and also useful proof of work, you can, let's say, mitigate the current issues and also have a sustainable model for generating the on-chain proofs. And we will see later what I'm talking about.
Yeah. Yeah. No, I mean, because I've been kind of like talking quite a bit about basically this concept of a type of hybrid consensus. And in particular, thinking about Ethereum in its current state, and to be very specific, thinking about, some of the monsters that are coming, like Alio, Monad, etc., things that are like designed with ZK in mind from the start, okay, that take this type of approach, wherein we can potentially expect performance characteristics that are significantly better than what we're seeing in Ethereum today. And so I'm just wondering, from a competitive standpoint, what does the future look like for Ethereum given its current state, and how would you think about ensuring or helping ensure that Ethereum can actually be competitive as these monster competitors come to market very, very soon,
But
if at all.
let's say, I would say, okay, doing a step back, we designed SNARKtor in a way that allows not only the proving being parallelized, but even proofs verification at the protocol level. So maybe I'm getting a little bit more technical, but if we currently look at layer 2s and ZK-based layer 2s where you have sequencers, the sequencers are becoming the bottleneck. So, and this is because you need to have a single actor executing all the transactions and calculating the state transitions, and this is the bottleneck. SNARKtor, I mean, for another reason, because he's aggregating proofs coming from the user, has the advantage of having stateless tasks to be verified, and so we designed it in a way that even the verification, not only the proving, even the proof verification can be parallelized among different actors. Why I'm saying this?
Yeah.
I'm saying this because if you start thinking further, when one of the biggest bottleneck of these layer 2s or layer 1 is the fact that the first traditionally in the original design, you have all the actors of the network that needs to run all the transactions to verify the validity of a block, for example.
Yes.
And this obviously is a big bottleneck. But also, even if you are able to remove these constraints and say just one actor is doing this, that will not work for some reason, but I mean, I will not go too much into details, but let's say even if it is one actor, this one actor will become the bottleneck. The computational power of this actor will be the bottleneck in terms of throughput.
Yes.
Now, let's imagine that we are able to parallelize even the execution, so amongst different actors. So this is the direction we are doing our research. That is a sort of a, let's say, next phase for SNARKtor. It uses some of his base concepts that would allow to parallelize the execution of the on-chain computation, not only the, let me say, part that was proven by the user, but also the on-chain computation. And this will allow to have a much higher throughput, and these will leverage for sure SNARKs, recursive SNARKs, and here will also come into play also hardware acceleration. And so when you were first speaking about having a hardware software co-design, I would have even extended more, because it's you have to have three things going together. One is on the protocol side, having something that allows you to scale and that can leverage zero knowledge, and then having an implementation of proving system that is hardware software co-design in order to get the benefits, most of the benefits of the hardware acceleration in order to make it scalable and also cost effective.
Yeah.
I mean, a lot of stuff in
No. This is exactly the kind of it's a hard conversation because I mean the current state of Ethereum I think has some serious limitations, and when you think about it in this context, especially from the perspective of parallelization and why it's so important, we can start to see where how big of a challenge we're actually facing, because at the end of the day, what we have to get to is user-generated proofs happening very, very fast.
Correct.
At a very low cost in order to create the demand wherein users are actually willing to avail of the proving markets, right? And so what we have is some fundamental questions, of course, research areas for us here at Telos and at Ponus as well. But I think it's very important to succinctly kind of describe
Yes.
This vision, some of the challenges.
I would add even one thing. I mean, we have to have user being able to generate the proof efficiently, but then also, as we are leveraging zero-knowledge proofs and SNARKs for the on-chain computation, I mean, also there should be efficient in order to have a higher throughput of the chain. And so that's the other aspect that we should take into consideration, both in how you design the protocol and both how you design the proving system in order to leverage hardware acceleration.
Yeah, and then maybe just one more kind of heavy question, Slobodan, if you don't mind, just on the topic of throughput, just kind of expand a little bit or talk a bit about how big of a problem, I mean, throughput really is and how important it is that we can achieve very high throughput in order to actually realize some of these goals at scale.
Well, just to say something on top of what Alberto said, we speak about end user as an individual that is producing his proof on his phone. You know what's the biggest deployed proving network currently? It's actually Filecoin. And they use ZK proofs as a proof of storage. And they produce something like 5 million proofs per day. So honestly speaking, I do believe that this kind of proving demand will mostly come for this kind of applications. And not for end user individuals who are checking in hotels and using and have to verify their digital ID. I don't know what are the numbers, by the way, excuse me, on ID, sorry, on ID, the digital identification. But I may tell you that this kind of stuff, and especially in DeFi, will practically be the main driver of increased TPS. If we look at current numbers, they're pretty low. And what we've done, for instance, with AMD, we are kind of building the first ZK kind of high-performance computing machine based on their recently released V80 alloy cards. And I can tell you that we can achieve something like 5 to 10 TPS with only one machine. It's at the level of the highest demand of, if you check publicly available numbers, it's at the level of highest peak demand of the main ZK projects at the moment. So this is just to compare current demand and something that we can achieve on the other side. So we are absolutely ready to scale this kind of solutions on our side. And I may say that, speaking about chicken-egg problems, chicken or egg or whatever, one side is ready. It's pretty much ready. And is not, of course, this is absolutely not perfected still, but we are on a very good path. We are moving, we are paving the way practically to very, together with solutions like SNARKtor, to wide adoption, providing fast and cheap proving as well. And the entire SNARKtor approach I actually see as a win-win solution in the sense that in this case we are trading verification cost, we are decreasing the verification cost by aggregating proofs. On the trading for higher proving demand because you have to have several iterations. And on the other side, we are actually decreasing proving cost, which is a win-win situation. That's the only way to achieve what we are actually considering as the most important thing, as efficient underlying infrastructures for whatever kind of proving. And I think that Telos as a network would be able to provide to other, not only third-party applications, but possibly also to other ZK projects, efficient solutions for aggregation and efficient solution for proving as well. That's my idea for some, let's say, midterm future. I hope that answers your question.
Yeah. No, it's definitely interesting to consider where the demand will initially come from and how we service the demand. I personally think that self-sovereign identity, it's one of those things that, I mean, I've been chasing for a very long time. When I was at Consensus, we worked on a project called Uport for many years. But of course, to Alberto's point, the limitations of having everything on chain really didn't allow for real traction. I also see other things these days, like you see the ENS stuff and now you can Google it and everything is there, and like it's a little bit, I mean, it's great to have transparency and everything, but I think when it comes to identity, once people begin to see self-sovereign identity, selective disclosure, granular authentication, the fact that they can just post a proof on chain, I think the uptake will be very, very fast, particularly with younger generation who are kind of native to this stuff.
Yeah, fully agree.
Okay, cool. So maybe we'll wrap it up. I guess just one kind of last final statement from each of you. Yeah, maybe just whatever you want to say. I guess kind of along the lines of how you feel about working in ZK, how you feel about our ecosystem, and maybe where you see all of us, not just Telos or Ponos, but this whole ecosystem going, let's say, in the next year.
Well, it's definitely really exciting and really, really, really challenging area.
Yes.
And as engineers, we do love such kind of challenges to try to tackle them and to compete with and to contribute actually to the entire community with respect of providing solutions that would enable this wide adoption. I'm personally very glad and honored to work with this kind of people coming from this kind of teams, as well as some other flagship projects in this field. I do expect myself that zero knowledge will definitely be widely accepted as is in regular industries. We may also discuss compliance, for instance. And in that sense, it's really, I'm flattered in a way to participate in this kind of endeavor. Me personally, as well as our team in Ponos, that is, I would say, I'm really proud of those guys and the stuff that we are producing.
Cool. Let's hear it. How do you feel about doing ZK?
I mean, I think that now it's the time. Okay, it took a while, but now I see all the elements that are, let me say, aligning together. So, I mean, very practically, currently we are working on the POC for SNARKtor that will showcase how the protocol will be able to, let me say, make zero-knowledge proof verification efficient, and will show how these new use cases, or better, new for blockchain, because they are out there. We are not just taking to blockchain so far. So these old use cases will become able and possible on blockchain, and with this POC, we will showcase it. But then we will move forward and deploying an hardware-accelerated ZK VM L2 integrated with SNARKtor. So you will start seeing user data protecting application and also on-chain computation more efficient because will leverage hardware acceleration. And in the next phase, going forward, what I just mentioned before, leveraging some of the principle of SNARKtor, and this is the currently in research phase, on how make the on-chain computation parallelizable, and leveraging again SNARKs, recursive SNARKs, and hardware acceleration. And this will give another fundamental boost in terms of throughput also to the on-chain computation, and keeping all the user data protecting features and compliance features as well. So, I mean, this is what I'm envisioning happening in the next upcoming months and years.
Yeah, very exciting stuff. Super
Yeah.
cool. Well, yeah, I guess that's it. So thank you guys very much. We should do this more often, kind of chat a little bit more, and super cool. Thank you for sharing your thoughts.